So, Mathmaniacs, this is Mrs. Long, and we are looking at a problem like number 3. The time it takes a train to travel between two cities varies inversely with its speed. When the train travels at 95 miles per hour, the travel time is 6 hours. How long would it take if the speed were increased to 120 miles per hour? All right, so the first thing we have to determine here is what kind of problem are we dealing with? And right here where it says varies inversely, tells me that it's going to be an inverse variation problem. And the formula for those guys is this. They say f of x equals k over x. Well, the next thing we have to do is establish which one's the input variable and which one's the output variable. We know that x is always going to be our input, so when we look at this problem, I believe that the speed of the train is going to be our input because the time it takes depends on how fast they're going. So this is going to be our input, or our x value, and the time is going to be our y value, or in this case f of x, because it is the output. Okay, so that is the output, which is f of x. So now I'm going to substitute those in here so that I can find my constant of variation, or k. So here I'm going to put in 6 hours equals the constant of variation over the speed. All right, then I'm going to use my calculator, and I'm going to multiply both sides by 95 because I want to get k by himself. My first step here is just to solve for k. Well, I know that these guys are going to cancel out. So on this side, I'm going to be left with k. And I have a fancy pink calculator here. So I'm going to do 95 times 6 on my fancy pink calculator. And I find that this is 570. That's my constant of variation. So now, that's not what it really asked me. That was what I need to know to be able to answer what it asked me. It says, how long would it take if the speed were increased to 120 miles per hour? So what I'm going to do is I'm going to set up the same formula here, f of x equals k over x, but now I'm going to be filling in different things. They want to know how long would it take. Well, we know how long is our output variable. It's our f of x. The time it takes is our output variable. So I'm just going to fill in f of x here. And then I know that k is 570. That's why we did that part of the problem, so we could find our constant of variation. And our input variable is our speed. That's this guy here. That's our input variable. So I'm going to put 120 here. Now, do you think when the train's traveling 120 miles per hour, should that be longer or shorter than the amount of time it took at 95 miles per hour? Yeah, of course. If you're going faster, it should take you a shorter amount of time. So we're looking for a number here that's less than 6, right? It should take less than 6 hours now. So I'm going to do 570 divided by 120. And I find now that it takes 4.75 hours. 4.75 hours. Now, if you were on a multiple choice test and they had 4 hours and 30 minutes, 4 hours and 15 minutes, 4 hours and 45 minutes, what would you choose there? Yes, 3/4 of an hour, or 0.75 of an hour, would be 45 minutes. So here, they would be traveling 4 hours and 45 minutes. All right, hope that helps. Good luck with inverse variation.